Hi. Hello friends, welcome to my YouTube channel. Now we will discuss second order transient circuits. So in second order transient circuits, first we will see the source free or transient response or natural response of RLC series circuit. After then we will go through the step response of series RLC circuit. So first we will see source free RLC circuit. So source free means there is no voltage source here. Second thing is who is going to provide the energy or current or voltage in this circuit is, for that analysis point of view, we will assume that the current, initial current flowing through the inductor is I naught. So inductor has charged today I of 0 is equal to I naught and V of 0 is equal to the voltage across the capacitor is V naught. So these are the two initial values across the energy storage elements that are indicated here. Now when the switch is closed at t is equal to 0 or t greater than 0, so because of this the current is flowing is I of t, which will causes a voltage drop across the resistance is, so plus minus VR here and plus minus VL here and plus minus VC here. Okay, so these are the voltage drops caused across the series elements. So by KVL applying in this loop, we can write, so first of all I am writing from here R into I of t plus L into d of t by dt plus 1 by c integration minus infinity to t I of t into dt. So this is nothing but initial voltage across the capacitor, that is V naught. Now by differentiating, initial voltage, by differentiating on the both the sides of this equation, so R into di of t by dt plus L into, so d square I of t by dt square plus, so when you differentiate here, so integration gets cancelled, I by LC is equal to 0. So by just altering the L value here, so R by L di of by dt plus d square I of t by dt square plus 1 by LC is equal to 0. So this is the second equation. So already we know this is a second order nonlinear equation. So second order linear equation. So here by assuming S is equal to d by dt from equation number 2, what you can write? So by substituting S is equal to di by dt, that means we can write S into I of t here. Okay, so R by L into S of t plus S square plus I of t by LC here. So we have written here. So here 1 by LC into I of t that we got. Okay, so this equation S square by R by L into S plus I by 1 by LC is equal to 0. So this is called as characteristic equation. We studied in case of control system. So control system, second order systems here. So from this equation, so this equation will give three different responses here. Okay, so this equation will give transient or source free or natural response only. Okay, so why? Because this term is 0 here, it indicates that particular integral, let's say at t is equal to infinity, what is the response? But here 0. So this equation will give only complementary function response. The roots of this characteristic equation decides the response. So what is the response? How the response will be? Okay, so we are taking this equation and we are writing the roots. So the basic formula is minus b plus or minus square root of b square minus 4ac by 2a. This is the basic formula for finding the roots. So here a is 1, b is r by l, c is 1 by lc. So b square minus 4lc by 2a. So if we substitute here, we will get the roots, two roots, that is s1, s2 is nothing but minus r by 2l plus or minus square root of r by 2l whole square minus 1 by lc. So here, in order to reduce this equation, we are going to define two terms alpha here. So alpha is nothing but damping factor. So we are defining a factor called damping factor. So which is nothing but alpha is equal to r by 2l here. And next one, omega naught is equal to 1 by square root of LC. The units are radians per second, which is also called as natural frequency of oscillations or undamped frequency of oscillations. So undamped frequency of oscillations is nothing but omega naught. Next one. So we will write in terms of alpha and omega naught. So S1 S2 is equal to minus alpha plus or minus square root of alpha square minus omega naught square. So from this equation, we are writing this equation here. Now, the complementary function gives the exponential term. That means it is transient response. So it will give the exponentially decaying or exponential rising function. So after a few seconds of time, after 5 time constants exactly, The response is going to be changes from its transient state to steady state. So here the equation I of t can be written as a1 into e power s1t plus a2 into e power s2t is the response. So how we got this means, if you solve this equation, you will get the response in terms of a1 into e power s1t plus a2 into e power s2t. So s1 s2 already we got here. So a1 and a2 are the integration constants. So integration constants are to be determined. We can find the integration constants from the initial conditions. Okay, so the response of this series source free circuit can be defined in three different conditions. So when the damping factor is greater than that of natural frequency of oscillations omega naught, then we can say over damped system. So if alpha is equal to omega naught means it is a critically damped system. Alpha is less than omega naught means it is under damped system. So we will see three different cases and we will derive three different responses here. How the current value will I of t will be there for these different conditions here. Okay, so first we will take over damped case. So when damping factor alpha is greater than omega naught. So what is alpha value? Alpha is equal to r by 2l. So which is equal to 1 by omega naught means the square root of lc. Okay, so alpha is greater than omega naught means r by 2l is greater than 1 by square root of lc. So squaring on the both sides you will get c is greater than 4 by 4l by r square. So whenever if you are given any series RLC circuit, source free series RLC circuit, just cross check this condition here. When c value is greater than 4l by r square means it indicates that the system is going to be give over damped response here. Now the roots of the characteristic equation s1 s2 is equal to minus alpha plus or minus square root of alpha square minus omega naught square. Since alpha is greater than omega naught means the response is negative value. Why? Because here we are having minus alpha. So response is the roots are real and negative. So the equation is I of t is equal to a1 into e power s1t plus a2 into e power s2t. Okay, so whenever we get over damped case means we will get this equation and we are going to find a1 a2 constants from initial conditions. So if you draw the curve of this nature you will get the shape like this. So I of t versus t graph looks like this. Okay, next we will go to the critically damped case. So in critical damped case alpha is equal to omega naught, so that C capacitance value is 4 times of L divided by R square. Okay, so what is the S1 S2? S1 S2 equal to minus alpha here. Hope you got this. So S1 S2 is equal to minus alpha plus or minus square root of alpha square minus omega naught square. When alpha is equal to omega naught means this root term is going to be 0. So S1 S2 becomes minus alpha only. So minus alpha is nothing but minus R by 2L. So I of t is equal to a1 into e power minus alpha t plus a2 into e power minus alpha into t. Okay, so s1 and s2 both are same only, so alpha will get here. So this is equal to a3 here. So here a3 is not equal to a1 plus a2. So we need to find what is the value of a3 here. So in order to find this a3 and a3, so by taking the characteristic equation s square plus r by l into s plus 1 by lc is equal to 0 is the characteristic equation that we got. So by substituting d by dt is equal to s, and we know that alpha is equal to r by 2l. So by taking these two and values into this equation, we will write this equation as d square I by dt square plus 2 alpha into d by dt plus omega naught square. Okay, what is omega naught square? Alpha is nothing but omega naught here. So by substituting here, we will get this is equal to alpha square. So d of dt into di by dt plus alpha into I. So I am writing this 2 alpha into di by dt into alpha into di by dt into alpha into di by dt here. Like this I am dividing. So d by dt into di by dt plus alpha into I plus alpha into di by dt plus alpha into I. So like that I am just making an equation like this. Now let a parameter called f which is equal to so di by dt plus alpha into I. So I am writing here like this. Now what is, by substituting this value in the equation, what you will get here is nothing but, so this is f become f. So d f by dt plus alpha into f is equal to 0. So this is a first order equation. So we are trying to solve the second order equation and converting into first order equation, and we are going to find the solution here. So when we have this kind of nature of first order equation, as we seen that the solution will be in the form of f is equal to a1 into e power minus alpha into t. So here I am taking another constant here, so a1, okay, e power minus alpha. Now what is f? So df, so f is nothing but di by dt plus alpha into I is equal to a1 into e power minus alpha t. So if we cross multiply this equation with e power alpha t, so e power minus alpha t into e power alpha t will get 1. So this is a1 here, which is equal to, so e power alpha t into d by dt plus alpha into I into e power alpha t. Now next, so this is in the form of d by dx of u into v, so where u into dy by dx plus v into dy by dx. So by writing this d by dt of e power alpha t into I, we can get a1 here. Okay, so again integrating on the both the sides of this equation, we will get integration of d of e power alpha t into I is equal to integration of a1 into dt. So this is going to be t. So finally response I of t is equal to a1 into t plus a2 into e power minus alpha t. So what is a3 becomes now? A3 is equal to a1 into t plus a2, but a3 is not equal to a1 plus a2. So in order to do this, we have gone through all these equations here. Now next case, we will go through underdamped case. So underdamped case means alpha is less than omega naught. So c is less than 4l by r square. So how we got this? By substituting the value of alpha and omega naught. The roots are s1 s2 is equal to minus alpha plus or minus square root of alpha square minus omega naught square. As alpha is less than omega naught means this thing we can written in the form of minus alpha plus or minus j omega d. So here the roots are going to be complex. So to represent this complex, we are taking it a parameter called j. Okay, so omega d is equal to square root of omega naught square minus alpha square. So this parameter j are in some textbooks denoted as I, complex parameter. Now the equation I of t is equal to a1 into e power st plus a2 into e power s2t. So s1t s2t. So what is s1? Minus alpha plus or minus j omega d. Omega d is nothing but damped frequency of oscillation, which is nothing but square root of omega naught square minus alpha square. So I of t is equal to a1 into e power s1 is nothing but minus alpha plus j omega dt t plus a2 into s2. So minus alpha minus j omega dt into t. So by making the e power minus alpha t as a common here, I can write e power minus alpha t into a1 into e power j omega dt plus a2 into e power minus j omega dt into t. So by Euler's identity, what you can write is we can convert this equation in terms of angle cos theta plus j sin theta. So e power j omega dt is nothing but e power minus alpha t into a1 into cos omega dt plus j sin omega dt. So here theta is nothing but omega dt substituting here. Similarly, a2 into e power minus j omega dt becomes a2 into cos omega dt plus minus j omega j sin omega dt here. Okay, so now by writing the equation again here, so e power minus alpha t into a1 plus a2 into cos omega dt plus j into a1 minus a2 into sin omega dt. So minus e power minus alpha t into b1 into cos omega dt. So b1 is nothing but here we are defining another constant b1, so which is nothing but a1 plus a2. Similarly, j into b2 is nothing but a1 minus a2 is another constant. So found from initial conditions here. So a1 a2 can be found from initial value of conditions. So if you take the under damped response, so under damped response, it is going to be decaying oscillations like this. Like this, it is going to be decay here. As we seen in control systems also same thing happens. So what is here? So 2 pi f is nothing but under damped frequency of oscillation. It start from here, so frequency here. Okay, so what is f? F is nothing but so omega dt by 2 pi. What is this time period? So this time period means t is equal to 1 by f is nothing but, so time period at t is equal to 2 pi by omega d is time period here. Okay, so let's take a simple problem based on this series RLC circuits. Okay, so here the question is having, so find the expression for I of t for t greater than 0, the value of current at 5 seconds after the switch is closed. So derive the formula used for the following network. So we already derived the formula for this network. take another ink, right? So now see here. So this is given. So R value is given, L value is given. So capacitor voltage is C is given here. That is initial voltage is 24 volts. So V naught is equal to minus 24 volts here. Okay. So in series RLC circuit, we are assuming that the current is flowing in this manner. So plus minus, plus minus, plus minus. But here it is in reverse case here. Why? Because current flowing in this manner is minus here. So that's why I'm taking V naught as minus 24. Now first we will check which type of damping here. So in order to find the damping, so alpha is equal to R by 2L. So what is this? R is equal to how much? 6 divided by 2 into 0.1. Sorry, it is 1.0. So L is equal to 1.0 here. So 1.0 means, so 6 by 2 is nothing but 3. And omega naught is equal to 1 by square root of LC, which is nothing but 1 by square root of L is nothing but 1. C is nothing but, so it is given as 0.2 farads. So my mistake. So 0.2 microfarads. Sorry, farads only. So 0.2 farads. So 0.2. So which will get as 2.236. So as alpha is greater than omega naught, so which case it is? It is overdamped case. So overdamped case it is, overdamped condition. So in overdamped condition, what is the solution? So I of t is equal to a1 into e power s1 into t plus a2 into e power s2 into t. Now what is the s1, s2 value? S1, s2 is equal to, so minus alpha plus or minus square root of alpha square minus omega naught square. So what is the value of alpha? Alpha that we got is 3. So minus 3 plus or minus square root of 3 square minus omega naught is nothing but 1 by 0.2 whole square. So this will give you minus 3 plus or minus square root of 9 minus, so 9 minus 5. So minus 3 plus or minus square root of 4. The roots maybe you get as minus 1 minus 5. I of t is equal to 1 to e power minus t, right? Now we got equation S1, S2. So now we want to find the values of A1 and A2. So in order to find A1, A2, we will take initial conditions. So at I of 0 is equal to, so before closing the switch. So before closing the switch means the network is considered to be steady state. So steady state means how it behave, how the inductor will behave. So L act as short circuit, capacitor act as open circuit. Okay, so I of 0 minus is nothing but 0 amperes. Why? Because open circuit is there. So that, so I of 0 minus is 0. Similarly, I of 0 plus is also 0. Why? Because inductor will never allow sudden change in current. So by taking this equation, so first of all I of 0. So I of 0 is equal to a1 into e power s1 into 0 plus a2 into e power s2 into 0. That implies a1 plus a2 is equal to 0. Okay, this is the first case. That implies the constants a1 is equal to minus a2. So remember this. Next one. So next what I will do is I will take another equation. So d I of 0 by dt. So how we will get this equation here is, in case of series RLC circuit, RLC, when the switch is closed here, so let's take RLC. So what's the equation that we have written? So I of t into R plus L into di of t by dt plus V naught is equal to 0. So we are writing in terms of the current. So what is I naught of t? So at t is equal to 0 initially, so I of 0 into R plus L into di of 0 by dt plus V naught is equal to 0. So from this what you can write? So that implies di of 0 by dt is equal to minus of I naught into R plus V naught divided by L, you get it. So what is I naught? I naught is nothing but minus of 0 into R is how much? It is going to be 6. So V naught is minus 24 divided by L is 1.0. So this is going to be 24 amps per second. So we will take this value and substitute here. Okay. So first, what is I of t? So I of t that we got here in this equation. So I of t is equal to a1 into e power s1t plus a2 into e power s2t. Okay. So s1 s2 we already found. We will take the equation here, right? So s1 is minus 1, s2 is minus 5. So this is equal to a1 into e power minus t plus a2 into e power minus 5 into t. So with respect to, we'll differentiate this one. So di of t by dt, and after that substituting t is equal to 0. So what you'll get is, so a1 into minus 1 into e power minus t plus minus 5 a2 into e power minus 5t. Okay, after substituting at t is equal to 0, so what you will get? So t is equal to 0 means we got this value is minus 24, sorry, plus 24. 24 is equal to, so minus a1 into e power 0 minus 5a2 into e power 0. That implies, so a1 minus 5a2 is equal to 24. By solving these three equations, you will get it as a1 is equal to 6, a2 is equal to minus 6. Okay, so we want to find at t is equal to 5 seconds. Okay, so after 5 seconds means you can substitute here. So I of t is equal to, okay, so what is the value of a1 here? We got 6, so we'll make a 6 common. So e power minus t minus 6 e power minus 5t. If you substitute t is equal to 5 seconds means 6 into e power minus 5 minus e power minus 25 amps is the answer here. Okay, so next we'll move to the step response of series RLC circuit. Okay, so in step response of series RLC circuit, just we are taking a voltage source here, so Vs, and we are closing the switch at t is equal to 0. So here we have R, L, C. Okay, now, so initially we are assuming that there is no inductor and capacitor having storage. So we will write the KVL equation inside this loop. So L into di by dt plus I into R plus Vc is equal to Vs, and we know that I is equal to C into dVc by dt. Okay, why? Because in series connections current will remain same, and we are substituting here. So L into d square Vc by dt square plus C into dV by dt plus into R plus V is equal to Vs. So from this equation is going to be d square Vc by dt square plus R by L into dVc by dt plus Vc is equal to Vs by Lc. So this is the second order equation. This equation has two components, that is transient component and steady state component. So if you make this Vs by Lc, this equation will give transient response. So Vt of t can be found by making Vs source is 0 means, so this equation we already solved. So this equation will give a second order equation. So s square plus R by L into S into plus 1 by square root of Lc. This is the second order equation. So if you solve the second order equation, just we have seen there are three different cases. So Vt of t is equal to a1 into e power s1t plus a2 into e power s2t. So this is overdamped case, just we seen. And similarly Vt of t is equal to a2 plus a1 into t. So in some textbooks they written, so a1 plus a2 into t. Okay, so both are same. This don't need to be worried. Into e power minus alpha t. So just now we have seen. So similarly Vt of t is equal to, so b1 into cos omega dt plus b2 into sin omega dt. So this is for underdamped case. Okay, so here this solution we have two responses. First one is steady state response, second one is transient response. So transient response we found here like this. In order to find steady state response, assume t is equal to infinity. So at t is equal to infinity, inductor act as short circuit, capacitor act as a open circuit. When inductor act as an open circuit, sorry, a short circuit capacitor acts as open circuit means because of capacitor open circuited after switch closing, so entire voltage Vs will appear across the capacitance. So Vc of infinity is nothing but supply voltage Vs here. So the total response. So total response will be Vc of t is equal to, it is sum of steady state response plus transient response, sum of steady state plus transient, sum of steady state plus transient response for three different cases here. Now I of t will be same for with and without source circuits. So why? Because at t is equal to infinity, capacitor acts as an open circuit. Anyhow, the current is going to be 0, even though it is a source free circuit, or it may be with source circuit. Okay, and the remaining procedure is same as we did. Now we will take one problem and solve this network equation here. So let's take, so here find V of t for t greater than 0 as a network shown here. So here the network is given 24 volts and I is flowing through this 1 Henry and 4 ohm series combination, and 0.25 microfarads is a 0.25 farads is a capacitance, and switch is closed at t is equal to 0. Okay, so at t is equal to 0, what we are doing, closing or opening the switch. So arrow direction is upwards, that means that we are opening the switch. So S is opened, so switch is opened here. So before going to discuss the finding the equation, so let me take at t is equal to 0 minus what is the condition of the circuit. At t is equal to 0 minus the switch is in open position or closed position, it is in closed position. So inductor act as short circuit, capacitor act as open circuit. So when the inductor act as short circuit, capacitor act as open circuit, so we will redraw the circuit here. So plus or minus 24, resistance is 4 ohms, short circuited inductor, capacitor open circuited, and here we have resistance of how much it is, 1 ohm. So what is current flowing here? So I of 0 minus flowing the inductor. So I of 0 minus is nothing but 24 divided by, okay, so 4 plus 1 is nothing but 4.8 amps. So 4.8 amps. And what about voltage across capacitor? So V of 0. So V of 0 minus is nothing but, which is the same across the resistor. So resistor current flowing is I of 0 minus into 1 ohm, which is nothing but 4.8 volts here. So we found V of 0 minus and I of 0 minus. So now we'll check the conditions, which case it is. So under damped, critical damped, or over damped case. So alpha is equal to R by 2L. So which is nothing but how much R. So when we are seeing this condition at t is equal to 0 after operating the switch here. So when you operate the switch, so resistor, so 24 volts, resistor is 4, inductor is 1 Henry, and capacitor here is so 0.25, and at t is equal to 0 the switch is open here like this. So it's a 1 ohm. When you are looking from the terminals of this point, so resistor is having here, it is going to be, so when you're looking from this point of view, the resistance is going to be 4 ohms, L is going to be 1 Henry. So alpha is equal to R by 2L. So R which is 4, L is 2 into 1, which is nothing but 2. Omega naught is equal to 1 by square root of LC. So what is the L value? 1, C value is 0.25. It is nothing but 1 by square root of 0.25 into 1, so which is equal to 4. Okay, so 4 means square root of 4 is nothing but, it is going to be 2. So we can say that alpha is nothing but 2, omega naught is equal to 2. So what is S1, S2? So S1, S2 is equal to minus 2 here. Okay, now what is V of t? So V of t is equal to steady state voltage plus A1t plus A2 into e power minus alpha means 2 into t. Okay, so what is VSS? VSS as we see is nothing but open circuit voltage, which is nothing but Vs is nothing but 24 volts here. Okay, now so we will write the equation as, so 24 plus a1 into t plus a2 into e power minus 2t. So this is the actual equation, and we need to find the constants a1 and a2. So how we are going to find? So first let me take v of 0. So v of 0 is nothing but how much voltage it is storing. So v of 0 that we got as 4.8. So 4.8 is equal to, so it's substituting t is equal to 0 in this equation. So 24 plus a1 into 0 plus a2 into e power minus 2 into 0. So from this we can get a2 as minus 19.2. okay, it's a constant, it is having no units. So next one, I will take I of 0. So I of 0 is equal to c into dv of 0 by dt. That implies dv of 0 by dt is equal to I of 0 by c. So what is nothing but, so 4.8 divided by 0.25, which is nothing but 19.2. So units are, it's going to be amperes per, sorry, volts per second. So 19.2 volts per second is the value. Okay, so at dv of 0 by dt at t is equal to 0, we substitute here, that is equal to, so dv dt of, what is the v of 0 value? 24 plus a1 into t plus a2 into e power minus 2 into t. So differentiate this equation, you will get it as, so this is going to be 0 plus, so d, so a1 into t means 1 plus 0 into e power minus 0. So a2, okay, so sorry, so from this what you will get is, so it is 19.2. so that implies a1 you will get it as so you only get it minus 19.2. by substituting these equations you will get it is, this one is a1 is equal to minus 19.2. now what is v of t? So v of t is equal to 24 minus, so a1 a2, so what is a2 value that we got earlier? 19.2 only. So here also we get 19.2. so 19.2 into 1 plus t into e power minus 2t. okay, so this is the final equation that we are getting here. So v of t is equal to 24 minus 19.2 into 1 plus t into e power minus 2t. so units are volts. okay, now next we will see source free parallel RLC circuits. So it is similar to that what we discussed earlier. So source free parallel RLC circuit. So here we are assuming that I0 is the current flowing through the inductor and V0 is the voltage across the capacitor here. okay, so by assuming V of 0 is equal to V0 and I of 0 is equal to I0 here, by writing the KCL equations we will get a second order equation, and we are going to find the S1 S2 roots here as we did in previous case. And if the the values that we got, alpha is greater than omega naught means it is damped case, alpha is equal to omega naught means critical damped case, alpha is less than omega naught means it is under damped case, and the coefficients and constants both are same here. Similarly, in order to find dv of 0 by dt means we will write this equation v0 by r, first equation, plus I0 is the initial current and c into dv0 by dt is nothing but initial voltage is, and it is the initial current across current flowing through the capacitor. So from this we will get this dv of by dt is nothing but minus of v0 plus r into I0 by rc. In problems this value I0 value may be negative, so depends upon the problem polarities will the I0 value will change. okay, similarly the step response of RLC parallel circuits. So here I am taking current source here, so RLC is connected in parallel fashion here. So by writing this equation v by r plus I into c into dv by dt is equal to is. So this equation will give two responses. What is the transient response plus steady state response. So So writing this equation, so we can found this coefficients as transient part as we did earlier. So is here, it is because of steady state response. So here there are three different cases: over damped case, critical damped case, and under damped case, as we seen earlier. So remaining procedure is same. Okay, so hope you understand this topic. Thank you friends, thanks for watching my video. If you like my videos, please subscribe and comment and share. Thank you. Have a nice day.